In chapter 3, we're going to do scatter plots and correlation. Okay, we're going to do scatter plots, correlation. We're going to do line of best fit. We're going to do least square residual lines and some interesting stuff. Okay, so some of this stuff you've actually done, right? You've done a scatter plot before. You've looked at correlations. Okay, how to measure how tightly or good the actual regression line is, right? Looking at the correlations, we've done that before. So let's go ahead and do that. So we're going to go ahead and kind of review that in the statistics from a statistics point of view. Okay, so let's go to page 153 and Explanatory. It says the explanatory and response variables. Scatter plot does what? Scatterplot or correlation. Scatterplot determines or shows, displays the relationship between an L1 and L2, right? One variable versus another variable, right? So let's say that we ran a regression line and the regression line came out to be, I'm making these numbers up, something like that. Okay, so it gives us the relationship between X and Y, right? And in algebra, usually we call the X would be the independent variable. And this would be the dependent variable, right? The Y would be, so that would be the independent and the Y would be the dependent variable. In other words, as X changes, Y changes with it, right? So in statistics, we have the same thing, okay? So instead of calling these independent and dependent variables, we have the explanatory variable and we have the response variable, okay? So one's a response variable because it responds along, right? So response variable. Well, yeah, response variable, and then you have the explanatory variable. So this would be the equivalent of the X, and this would be the equivalent of the Y. This would be the equivalent of the independent variable, and this would be the dependent variable, right? So if you go to page 153, there's a green box there that explains the response and the explanatory variable, okay? So the response variable measures an outcome of a study. An explanatory variable may help predict or explain the changes, okay? All right. So let's go and see if we can do the example on page 154. Example of page 154. We have diamonds and the SAT. Okay. Explain the explanatory variable and response variable for the following relationships. A, the weight in carats and the price in dollars for a sample of diamonds. Okay. So what's going to respond to what? Okay. So in this case, obviously, the value or the what is it? Is it the price? The price of the ring is going to respond to how many carats you have, right? The more carats there are, the more expensive it's going to be, okay? So the weight or the carats would be the explanatory variable, and the price would be the response because it responds to the different weights, right? B, the SAT math score and SAT evidence-based reading and writing scores for sample students, okay? So what's the relationship here? What's the obvious relationship here, right? There really is none, right? Because they really don't go hand in hand, do they? Because if you're if you're the evidence-based reading and writing score, right, is not a good predictor or has really no relationship with your math score, okay? All right, so either one could be the explanatory variable and one could be the response variable there. Okay, so let's move on to scatterplots. In the middle of page 154, there is a definition there. Go ahead and read that for me. You can go and read it. Read what a scatterplot is. Okay, nothing earth-shattering there. You've done a scatterplot before, so there really isn't much to say. Go to page 155. How to make a scatterplot. Go ahead and read the 3 steps there. You basically label the axes and you scale them such that all the points would go in. And then you go ahead and just plot them out, right? And how do we do this in our calculator? We did stat plot, right? We did stat plot. We populate them in L1 and L2, and you just go ahead and do a stat plot on them, right? The next example says buying wins. Okay, on this one, you have a baseball. It says, do baseball team that spends more money on players also win more games? Well, in theory, you would like that to happen, right? If you're the Yankees, right, you spend and you spend and you spend like the Dodgers, right? They were spending up to like $280 million for, payroll at one time. You hope that that would translate into more wins. It's not guaranteed, obviously, right? Because if you spend money in the wrong places, right? You're not going to get the more wins, okay? So you would hope to see that. So if you flip the page, you see the scatter plot there. And what does the scatter plot say? What can you deduce or what can you discern from that scatter plot? Is it absolutely true that the more the money you spend, the more wins you're going to get?
Not really, no.
Not really, right? And that's kind of the part of the whole game, right? If that was the fact, then everybody would just spend more money and get more championships, right? Okay, so if you look there, you have a scatter plot that kind of looks like this. Okay, so this is the salary, and this here are the wins. Okay, so the salary is the what variable here? What variable gets placed here on the x-axis?
Explanatory?
The explanatory variable, correct. The wins would be the response variable, okay? So where do you want to be? Where's the place that you want to be here? You want to be over here, right? You want to be in this area right here where you're spending little salary and getting many wins, right? Where you don't want to be is down here, right? You do not want to be here because this is where you're spending lots of salary and getting little wins, okay? All right, okay. So how would you describe this scatter plot? Anybody, how would you describe this scatter plot? Is there a correlation? Is there association? Is there an association? I mean, if you were to draw a line of best fit, it's going to look like this, right? I'm going to guess it's going to look like this. Okay? Which means that, yes, definitely there is a correlation. It seems to me the more salary you spend, right, in general, you're going to get more wins. Okay? Which kind of makes sense. Okay? All right? Would you call this a strong relationship or a weak relationship? Anybody? Nobody? Anybody? Everybody awake today?
Is it a positive correlation?
It's a positive correlation, right? Because this is it's a positive slope, right? We already talked about that. The question is it a tight or is it a strong or weak?
Weak.
It's somewhere between weak and strong, right? It's not necessarily weak. Well, I guess you could call it a weak. I would not call it a strong correlation, okay? Because there are some outliers here. I'm not always saying outliers, but there are ones that are far away, okay? All right. They're not all populated close to the line, right? Okay. So let's go to page 157. And in the definition, there is a definition of what is a positive, negative association, and no association. Okay. So this is a positive association. Go ahead and read the green box. Okay, so this was a positive association. What would this one be?
Negative.
It should be a negative, right? Because you're definitely going down, right? If I were to draw a line, it would be like this, right? This would be a negative association. This one here,
No association.
this one is just all over the place, right? It's just so random, so it's no association, right? Okay. So underneath page 157, it shows you how to describe a scatter plot. What do you have to write there? Okay, you have to write whether it's a positive or negative. That's the direction, right? Whether it's positive or negative. Okay, and then the form. Is it a linear relationship or not? Because you can find, you might find some scatter plots, and the scatter plots are going to look like that. Okay, this is not a linear relationship, right? This looks like more, it's going to be of a parabolic relationship, right? Okay, so that's the form, whether it's linear or not. Okay, and then the strength, is it weak or strong? Okay, and then there's the unusual features. Are there any outliers? Okay, so those are the things that you have to mention when you are asked to describe a scatter plot. Okay, so let's go to flip the page. Flip the page, go to 158. Okay, there's a red dot there on the top. It says, even when there is a clear relationship between the two variables in a scatter plot, the direction of the association describes only the overall trend, not an absolute relationship. Okay, that makes sense. Let's go to the example. There's Old Faithful and Fertility. So in the first, on the one on the left, looks like you have Old Faithful there, the duration versus the interval. And then on the other one, you have the average income versus fertility rate. Okay. So how would you describe the one to the right, the fertility rate? Is that linear? Would you consider that linear?
Yeah.
I
Kind of.
think so.
It looks
It goes down like this, doesn't it?
Oh,
You know, so
I
it's
thought you were talking about the
exponential,
first one.
exponential.
right? So it looks like this. So it's not a linear. Are there any outliers there? The book says there are potential outlier with the average income around 30,000. Around 30,000. Oh yeah, you see that one dot that's way out there by itself? That has about, it's approximately, the fertility rate is about 4.8, 4.6, somewhere around there. That one dot, that's an outlier. Is it pretty strong? It looks strong because they're all kind of populated together. Okay. So that would be the B. What about the A? What can we say about A? Is that a linear relationship?
Yes.
That one is a relationship. That has a definite linear relationship, correct? Right? There's definitely a linear relationship. Any outliers? There could be a couple possible ones there, right? At 2.5 and about 45 minutes. There's one at about 4 minutes and way up there around 110, 120 up there. Is it strong? Looks pretty strong. But what's the most distinguishing feature about this?
There's like a blank spot in the middle.
Yeah, exactly. So there are two definite huge clusters there. Can you see that? Right? So what did the book say? The book said there are two main clusters of points, okay? All right. Okay, so that's that. And we're not going to go over the Technology Center corner because you know how to do a scatter plot. And then let's see, where is that the first? Am I done with the first part? Okay, okay, yeah, we're done for the first part. So let me go ahead and